All right, let's see. Back to parallel circuits. The total resistance of the parallel circuit is always less than the smallest resistor. That is something you definitely want to keep in your head, because if I said, well, we have 10 resistors. We have a 3, a 4, a 5, a 6, 7, 8, 9, 10, on and on until I got to 10 resistors. What is the total resistance? And you would say?
Lower than 3.
It's lower than 3. Boom, done. Okay? All right. And do you remember, I want to bore you with the same stories over and over again, but why is it? I told you the story about going to San Francisco, across the Bay Bridge. Everybody remember that one?
Oh, yeah.
No. Johnny's saying no. Well, okay, so never know because you're a combined class. So this is the way I look at it, and I explain it. So it worked for my head. So hopefully it works for you. So resistors, right? So everybody go to San Francisco?
Oh,
Yeah, remember that now?
which way do you take? Yeah.
So all right. So if we were going to San Francisco and Caltrans decides they're going to put toll booth up, but they have one lane road going to San Francisco, and they put one toll booth every 10 miles. So you're one lane road, you're going, stop at a toll booth, right? And then another one. Is that series or parallel? Series, right? Okay, and so you and the car are the current, and you have to follow one path, and everybody behind you has to follow one path, and everybody in front of you has to follow one path. So there we go. So that is toll booths in series. Every time they add another toll booth, it takes you longer to get to San Francisco, which may be a good thing. I don't know. So every toll booth is resistance. But then they said, well, wait a minute. Let's build superhighways. You know, you got Interstate 80 and 5. 5 doesn't go there, but 80 does, right? And so they said instead of one toll booth every 5 or 10 miles on one single lane road, let's build the superhighway with, when you get to, I don't know, when you get to the Bay Bridge, what is that, 20 lanes across or more? At least. And they say, well, we're going to put them all this way. And it says that series or parallel? Parallel. Okay, so each toll booth has the same resistance, right? You can only let so many cars through per hour. So opening day, they've got one toll booth open. And the line of cars goes from San Francisco all the way to Livermore, right? So, but every toll booth is restriction. We agree to that?
Sure.
So, but they opened the one next to it. Did they add a restriction?
Yes.
They did. They opened a toll booth. That's a restriction.
Okay.
But now what happens? The total resistance to you getting to San Francisco went up or down?
Yeah.
Down. They opened a third one. Did we add a resistor?
Yes.
And the total resistance just went down again, because more cars can go that way. So every time you open a resistor in parallel, resistance goes down. Especially with fast track. And then we got Judy working over in the booth, and she's been there 50 years, and she can only do 1 car an hour. So the total resistance is less than Judy. I don't know how that works out. I haven't thought of that one. Okay.
Sounds like a Q&A.
Yeah. Let's see. Total resistance. Bug. So the amount of current passing through each resistor, amount of current passing through each resistor, or load if you want, will vary according to its individual resistance. In other words, old Judy, she's not going to be doing so well. She's only got a couple cars per hour, but a couple lanes over, we got Sally. And why they have to both be women, I don't know. But she can do 100 cars per hour, so that'd be a lot. I don't think so. You should be doing like one every, 15 seconds or so? All right. Formulas. So with these resistors in parallel, there are multiple formulas, which I didn't tell you in 309, but I will tell them to you now. If you have 2 resistors, if you have two resistors,
Let's do it for parallel.
parallel, all talking parallel. Don't try this at home with the series. The resistance total is equal to resistor 1 times resistor 2 divided by resistor 1 plus resistor 2. I use this formula exactly twice a year. Once today and once a year ago today. And I will use it again once. I don't even know it. I'm just like, what? So if you had two resistors and they were 4 ohm and 5 ohm, then it would be 4 times 5 divided by 4 plus 5. So that would be 20 divided by 9. And so our total would equal 2.22. Is the total resistance less than the smallest one?
Yes.
Yes, I'm double check that. If they are like resistors, sometimes you have a couple resistors that are the same. So our total, oops, sorry, I need to tell you what I'm talking about. Like resistors. And when I say like resistors, I mean resistors are the same. This is not like my daughter talking like she says like all the time. Like resistors. Like resistors. So they're all the same value. Our total will equal the resistance divided by the number of resistors. This could be, kind of cool. So you had a 5 ohm and a 5 ohm and a 5 ohm and a 5 ohm. Then you could just do it this way. You would have 5 ohms divided by how many are there? 4. So our total would equal 1.25 ohms, and that is smaller than the smallest resistor. That still works. So if you want to remember that one, there you go. That one's kind of cool, but honestly, I just don't remember it. I'm like, I forget what it is just because I don't use it enough. So then there's this one where you can use for any circumstance. So in my little brain, I'm just going to remember this one because it works all the time for everything. And that is 1 over R1 plus 1 over R2 plus 1 over R3, and all of that 1 over. Right, so for example, if we had a 4 and a 5 ohm resistor, like we had before, on your calculator, it is 4 x minus 1 plus 5 x minus 1 equals, and you're going to get a number, 4 x minus 1 plus 5 x minus 1 equals 0.45. Now you have to head to the x minus 1 key again, equals, and you get 2.22, which is what we got before up here. 2.22. Or we said a little bit ago, what did we have? 5s. We had a 5, a 5, a 5, and a 5. Is that the next example I gave you? All the same?
Yeah.
5x minus 1 plus 5x minus 1 plus 5x minus 1 plus 5x minus 1 equals 0.8. We're going to hit the x minus 1 key again, the equals key, and you get 1.25 ohms, which matches what we did before. I think that was the only examples I gave you. All right, there is a formula for when one resistor is missing. Okay, when one resistor is missing. In other words, if R total equals 5.71 ohms, and you have R of 1 equals an unknown, R of 2 equals 20, and R of 3 equals 30, then what is R1? Oops, it's actually 40. Sorry, this is 40. In my paper example here, 40. Oh my gosh, I want to go with this. Want me to show you how to do it?
Please.
Well, okay. First I'm going to tell you how to do it, then I'm going to show you. This is how you do it. You're taking an FAA test, right? And it's multiple choice. And so they're going to give you A, B, or C. So they give you A, B, and C. A is 4 ohms. B is 6 ohms, and C is 10 ohms.
Mm-hmm.
Okay, and there's your problem. How are you going to solve that?
Plug and go.
Okay, first of all, it's what?
It's not 6
Our
to 10,
total has to be
less than the smallest one.
less than the smallest. So which one can I eliminate?
6 and 10.
No.
Oh, it has to be lower than 4.
5 has to be. All right, so it's.
The total has to be less than all the rest, so 4 has to be eliminated.
That's the answer. So 4 has to be less, right? Because our total is smaller than the smallest. So if it's 4, 20, and 10, can it be 5.7?
No.
Nope. Okay, so if it's 6, 20, and 40, could it be 5.7?
Yes.
It could. So really quickly, 6, 1 over x, plus 20, 1 over x, plus 40, 1 over x equals 1 over x equals, and my answer is?
Not 5.71.
It equals 4.14 ohms. So is that the right answer? Nope. All right, let's try 10. So 10, 1 over x, plus 20, 1 over x, plus 40, 1 over x equals 1 over x equals. That equals 5.714 ohms. So what's your right answer? C. That's how I'm going to do this one.
Okay.
Because I think there's 2 of them on the FA test.
Thank you.
All right. The example that they give you, you guys good over there? I can help. No, if you had a question, probably something else.
Where the button was 1 over x.
Did you find it?
Yeah.
Okay. Everybody has, it's x minus 1 on
Yeah.
that calculator. All right, so it's R total equals 1 over R1 plus 1 over R2 plus 1 over R3. So that's the 1 over right there. So we're going to move this over to here. So it's 1 over R total, which was 5.71, equals 1 over x, that's 1 over x, which is our unknown, plus 1 over 20 plus 1 over 40. Then solve. So 1 divided by 5.71 is 0.175 equals 1x, because we can't solve that, plus 0.5, I'm sorry, 0.5, plus 1 divided by 40 equals 0.025. All right, combined like terms, well, solve what we can. 1.75 equals 1 over x plus 0.5 plus 0.25, 0.075. All right, let me think. Now we got to solve for that. So we have subtract. What are we going to subtract?
0.075.
Exactly, 0.075 minus 0.075. So we're going to end up with 0.1 equals 1 over x. And then we, what's that? Invert? So invert, so, or divide both sides by 0.1, I guess you will. So we get x equals 10. That's way too complicated. I'm not going to do that.
Make the time, right?
Right. So yeah, I divided by both sides by 0.1. Divided by 0.1. So that equals 0.1 divided by, oh, I'm sorry. 0.1 divided by 1. X equals 10. Yeah. Not going to do that. But you can plug it back in and check it. See, that's what I'm saying. It's like, why? Normally I don't even teach that. I don't even go through that. I'm like, I don't know. Probably shouldn't have subjected you to that. So there you go. I showed you how the easy way to do it. What the heck is that? Oh, let's check again. All right. Good with that? I probably just lost everybody on that one. Do you need to know that? No. No, you don't. How are you going to do it if you have one missing? You only have 3 options. Just take a minute and plug all 3 of them in and try it. Right? It took us less time to try 3 things than it did to do that. All right.
Fair enough.
Huh?
Cancel one out, it's a 50-50 chance.
There you go. It was. All right. See if I have anything here we're talking about. I'll tell you what we'll do. Pause. I'm not going to watch this ever, so that's on you. I don't care. All right, there you go. There's the answer. All right.
Series parallel, maybe they should-
Well, before I move on to series parallels, anybody want to tell me where this tripped them up? Where was the problem?
Units.
So the units is the problem. So, yeah.
I actually put it in as 14 milliamps.
You put it in as 14?
Yeah.
What do you mean? Yeah, 14.
0.4 you missed?
I'm sorry. At the very beginning, so I got 8.75 volts, but then I realized I crossed everything off.
Oh, okay. So you missed the 0.4 on the end.
Yeah.
Got it. Okay. Well, that's just a... But what I'm looking for is where are people having trouble with this? It's the milliamp to amp conversions, the kilo, or is it more along the lines of, man, I just didn't get that, how to convert 10K, 2K, and 1K into a total.
Can you do that one? The way you just...
Yeah. So, all right. Let me see here. Try to find something somewhat interesting, if such a thing exists. Well, I guess it doesn't matter. I mean, this one, I have one here. 3 resistors in parallel. I've got 12 volts total with resistor 1, resistor 2, resistor 3. And let's see, this one, I have to do it to the left. Yeah, that's fine. This one can be 3 ohms. This is 6 ohms. And this is 12 ohms. All right, so the real problem, if I'm understanding correctly, starts with how do we solve for our total, correct? Okay, so we're going to go back and use just one formula, which is our total equals, that's 1 over R1 plus 1 over R2 plus 1 over R3. Now, the calculator I used to use, it had a 1 over X key. All right, and that represented this 1 over right there. So I had 3, so I would hit 3 and then the 1 over x key, right? Which tells me that that 3 goes down here. But this blue calculator doesn't have that button. All right, it doesn't have that button. It has a different button, which means the same thing, and that's x minus 1. So you follow me so far? Okay. So now we have 3, 6, and 12. So move down here. So we have 3, 6, and 12. So it's 3. Okay. Then we're going to hit that x minus 1 key. Got that? Then the plus key.
6.
Now 6 key, x minus 1 plus,
No.
thanks, 12, it's a 1 and a 2, x minus 1.
Also no.
All right, so 3x minus 1 plus 6x minus 1 plus 12 x minus 1. Now I'm going to hit equals because I want that number. And what does that equal? Okay, that's what I have 0.58333. Okay, so let me show you where you're at right now. So we have our total equals 1 over 0.583. That's where we're at. So we still have to get rid of this 1 over here. So what we want to do is hit the x minus 1 key, or the 1 over x, same thing, equals, and that's what that does. That does the 1 over.
1.7.
What'd you get?
1.7.
1.715. Now remember this 1 over, that's really just saying 1 divided by. Your calculator just gives you a nice little shortcut. So it's 1 divided by 3 plus 1 divided by 6 plus 1 divided by 12 equals 0.583. Well, 1 divided by 0.583 equals 1.715. But your calculator has the shortcut, which we call x minus 1. It does that for you. Do you follow that now? Okay. So going back up here to finish that off, what did we get?
1.7.
1 point, where's that changed when I did it? 1.715 ohms. Now remember, in a parallel circuit, what stays the same? Voltage. So 12 volts, 12 volts, and 12 volts. So now we just have to solve for I. We use Ohm's law, where I equals E divided by R. So 12 divided by 12 is
1 amp.
12 divided by 6.
2 amps.
12 divided by 3.
4 amps.
And 12 divided by 1.17. Well,
7 amps.
we can just count 4, 5, 6, 7. But I'm going to check it. So E, 12, divided by 7 equals 1.714. Close enough. Yep.
Beautiful.
Why do you do the E first for?
Why did I put the 12 across the top?
No, like you said E. You said 12 divided by 7.
I just decided to, I don't know, you can do anything. I had all 3 numbers. I just want to check to make sure all 3 of them match Ohm's law.
Jesus.
So I could have done 12 divided by 7, or I could have put 7 times 1.715 equals 12 equals 1.715, or what's my third option here? E 12 divided by 1.715. I just wanted to do one of these things right here and make sure that the third thing worked out. Not in this class, with some exception. But the other classes, oh my gosh, I'd say all the time, what is this, Ohm's suggestion? Because they would have something written down like this, and it would be, like one of the answers down here would be something like 18. They would do, I'll make it red. It'd be like 18. I'm like, well, wait a minute. How is that 18? If that's 12 and that's 7, is that 18? No, it can't be. Can't be. So I'm like, you didn't do Ohm's law. So stop and just double check your work. That's all I'm saying.
So The V and the A's. What's the word for those? And
The what?
The resistance. Those are symbols, right?
The D and the A.
No, the V and the A and the
Volts, amps, resistance.
Right. Those are the symbols, or how do we like? What's the word for those? The units.
Amps.
Units.
Okay.
Yeah.
Mm.
And then the E and the I and the R and the W for watts. What are those called?
For what? No. Watts power.
What are they?
Like what could be a word that I can use?
Units still work for that?
For watts, E is a symbol.
Yeah.
It would be
So
the
the
symbol.
symbol.
It's
Okay.
Yeah.
a placeholder, right? Like these are units.
Beautiful.
Kevin,
Yeah.
I had a question.
Oh, hey, welcome. You woke up. How was your nap?
So, earlier on.
Before you fell asleep.
So, 1 volt, it takes 1 volt to move 1 amp over 1 ohm.
Yeah.
How does that apply to any of this? Because they're not as proportional.
It's the same thing. It's Ohm's law. So what that statement is,
How does it tie into this?
in a practical way, it doesn't to me. I just felt that I had to say it because it's like it's in the book. I think it's a Q&A question. I think it shows up, but it doesn't mean anything to me because it's all one. So I'm like, thank you for the help, but no thanks. It didn't work.
Fair enough.
So you can't help us here at all.
Well, I think you're saying that since it's proportional, if 1 equals 1 equals 1, if 1 goes up, the other has to go down for the to all be equal. I mean, that's
Yeah, that's a good way to put it. The way I was thinking of it is you have Ohm's EIR, and if it's 1 is 1 is 1, well, that's just a mess because it can, which way you talking here? It doesn't make any sense. So that's why I don't hang too much credit on it or use it. I don't use that as an application to anything. I just do the EIR. That's my application.
Put it on the back burner.
In fact, it's funny, honestly, like the first 2 years, 3 years I taught this, I never said that. And then somebody kind of brought it up. Well, you're not teaching them, the basic Ohm's law where 1 ohm equals 1 amp. I'm like, no, because it really doesn't seem to help anything. Well, I think you should be teaching that. Well, fine, I'll do it. So now I added that sentence, and here we are.
Fair enough.
Because to me, from the beginning, it was like, yeah, what kind of help is that? Oh, let's have some fun. We have a battery. What is that?
Motor.
Should know. So what?
Motor.
That is a. And you know what that is. It's a spring. Thank you. Thank you for that. It is, but it's made out of resistive material, so it becomes a resistor. All right, so I didn't leave myself a lot of room. I guess I could, do the magic of this. I can just do that. Now there's plenty of room, isn't there? EIR. So this can be a 14 volt. 14 volt system. I have a motor. What kind of motor? Well, it is a 7/8 horsepower motor that is 65% efficient. I have a landing light right here that is 100 watt landing light bulb, and my cigar lighter, which will be 2 ohms. There we go.
Your values for your length are screwed up. You better.
All right, got it?
Need.
Anybody completely lost? There's 3 things you can fill out instantly. At least get that done. That makes 4 things. That makes 5 things that quick. 1, 2, 3, 4, 5 things you can do super fast. That'd be the volts, 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 I, and then P. See that? Then you should be able to work the light bulb back real fast. Now you're just going to be stuck on the motor. Well, it is time for you guys to go. We can pick this up tomorrow.
Fair enough.
There's a lot to unpack.
Thank you.